Hello everyone. Today we're going to learn a little bit about the states of matter. So there are generally three states of matter that are usually discussed: the solid, liquid, and gas phases. There are others, but these are generally the three categories that we talk about. The solid state is a state of matter that has consistent volume and shape. Some examples of solids that you might see in your everyday life include a table, a chair, a pencil, or even a person. The liquid state is a state of matter that has a consistent volume, but an indefinite shape. The reason it has this indefinite shape is because liquids are able to be poured into new containers. Some examples of liquids you might be familiar with are water, lemonade, isopropyl alcohol, and other similar alcohols. The gas state is a state of matter that has neither definite shape nor definite volume. Examples of gases that you might be familiar with from your everyday life include the oxygen that you are breathing in right now, the carbon dioxide that you are breathing out, as well as things like helium, which helps to make balloons inflate. There are other states of matter that can exist because not everything fits neatly into the categories that we have described here. For example, plasma is another state of matter that is often discussed. It is a very condensed, high energy state that is very rare on Earth. Most commonly, it is found in the form of lightning on Earth or off of Earth in the form of stars such as our sun. Basically, it is places where it is too hot to remain a liquid, but too condensed to remain a gas. There's also non-Newtonian fluids, which are fluids whose ability to flow does not stay consistent at a given temperature. An example of this would be the Guyock combination that we saw, which was a combination of water and cornstarch. When it is hit very quickly, it suddenly acts as if it is a solid, but if it's allowed to flow very slowly, it acts more like a fluid. So it doesn't quite fit into either the solid or liquid boxes. Let's look at some more detailed properties of solids. Solids have rigid structure to them. This is why they have that definite shape. They cannot flow, nor can they be poured into a new container. The particles of a solid state are very close together, as shown in the diagram on the right here. They are practically touching, although not technically touching, just almost touching. Because of this, solids generally end up with much higher densities than other states. If you'll remember, density is a measure of the mass per volume. Because I have more particles, I would have more mass that I fit into a certain space, and therefore I would have a higher density. There are exceptions to this, including water. Particles of a solid state also move at much lower average speeds than they do in the other two primary states. Because of this, the particles of a solid state have a much lower average kinetic energy than their counterparts would in the liquid and gas phases. The liquid state is capable of flow and can be poured. You'll notice in the diagram here on the right, the particles of the liquid are still relatively close together, but they do have some space. It is because there is that space that they can squeeze past each other and are able to flow. Speaking of how close the particles are to each other, they are still relatively close. There's only a little bit more distance than there is in the solid state. Therefore, the densities of liquids are generally just a little bit smaller than they are for the liquid state. A key exception to this would be for water, where ice is actually less dense than the liquid state is, but water is an exception rather than the rule. Particles for the liquid state move at an average speed that is somewhere in between that of the solid and the gas states. And therefore, liquids have an average kinetic energy that is somewhere in between the two as well. Let's take a look at gases. Gases are also capable of flow and being poured. This is perhaps a little strange to consider because most gases that you know of are invisible to the eye. But consider when dry ice is added to water in order to make a fog effect. As the fog rolls out from the source, you'll notice that it moves very slowly as if it is being poured or flowing. This is an example of the gas doing that flow that it is capable of. Particles of the gas phase are very, very far away from each other, as shown in the diagram here on the right. There's generally a lot of space in between them, and they only collide into each other because of their high speed. Because of how much space is in between them, gases generally have much lower densities compared to the other states. The average speed of gas particles is also very, very high. Because of this, gases have a much higher average kinetic energy than they do in the corresponding other states. I mentioned on the previous slides kinetic energy, which is one of many different kinds of energy. Kinetic energy is the energy that is associated with movement. The formula for it has it relying both on the mass of an object and also on its speed. But let's just focus on speed for now. The higher the speed is, the more there is kinetic energy. Basically, the faster you're moving, the more kinetic energy you have. Gases, because they move very quickly on average for their particles, have a very high kinetic energy, while solids have a very low kinetic energy. Another kind of energy, usually talked about as the opposite of kinetic, is potential energy. Potential energy is an energy that's associated with the position of something or where it is located. For example, consider a ball at the top of a hill has potential energy. It has the potential to roll down the hill, converting its potential energy into kinetic energy. Or also consider an extended spring. If the spring were released, it would begin moving. Again, its energy would be transferred into kinetic energy as it moves to try to spring back into place. This is an example of spring potential energy or elastic potential energy. Chemical bonds also intermolecular forces house a type of potential energy often referred to as chemical potential energy. The idea of when those are broken, an energy change will occur. Solids, because they are very close to their neighbors, they have many interactions with their neighbors and therefore have a lot of stored potential energy because they have many interactions that could break and cause energy changes. Gases, on the other hand, are very far away from their neighbors and have few, if any, interactions with their neighbors. So therefore, they have very low potential energy. So as you can kind of see from this, the energy that is present is still pretty consistent. It's just in different forms in the different states. So that's it for now. This was just an introduction to the different states of matter. Good luck.